Good afternoon, sir.
Good afternoon, sir. Screen share వస్తుంది. 1 second. Okay, thank you.
Sir, paper name, sir, please.
Operation Research 10 AB Mathematics, sir.
Page number చెప్పగలరా?
Sir?
Page number, sir, చెప్పగలరా?
Page number, you mean?
Which topic? Which topic?
Which topic you started, sir?
Topic is last class we discussed, that is a assignment problem completed. Now in this class, a traveling salesman problem, transportation problem we will discuss. Transportation problem, unit 7.
7.
Unit 7, transportation problem. Sir. అదే ఇచ్చారు, లింక్ ఇచ్చారులేండి. యాక్చువల్లీ షేరింగ్ రాలేదు. హలో హలో మా స్క్రీన్ కనిపిస్తుందా?
Yes, sir.
Visible.
Okay, fine. Thank you. Now here, in this session, here we will discuss that is a total transportation problem. In that transportation problem, first we should be identify that is the initial basic feasible solutions. Then after that, we will identify the optimal solutions. The finding of initial basic feasible solutions, we have 3 methods in the transportation problem. First method is called as a northwest corner method. Northwest corner method. Second method is called as a lowest cost method or matrix minimum method. Third method is called as a Vogel approximation method. By using these methods, we will identify that is the initial basic feasible solution for the transportation problem. Now, your finding of that initial basic feasible solutions, we have 3 methods. From these 3 methods, whether we can get that is the exact answer or not, the testing point of view, another 2 more methods we have. The methods are called as a UV method, and another method is called as a stepping stone method. UV method is called as a modified distribution method, MODI method, modified distribution method. At last, we will study that stepping stone method. Both are almost similar, but a small variation will be there that we can be sure. I will discuss in the class. That is a stepping stone method. So with this, the total transportation problem we can be complete. Here after that, it is in that transportation problem, special cases, if anything will be there, that will be the only one thing is the unbalanced transportation problem. Unbalanced transportation problem means it is a supply and demand, both will be the same, equal. What is the supply, what is demand, I will show you here. Supply and demand both are the same, then it is called as a balanced transportation problem. So above method directly we can apply and we can identify the solution. Whenever we are not a unbalanced, it is not a balanced. Not balanced means it is unbalanced. Supply is not equal to the demand. At the making that is a balance, we will introduce one dummy row or a dummy column. The problem unbalanced will be converted into the balanced transportation problem. From that we can apply that is the previous methods. This is a overall idea about it. It is an unbalanced transportation problem. Solution, how we can be identified. That is the last concept we will study. Next, it is any such cases in the degeneracy. These are the special cases. Degeneracy in the transportation problem. At the time, degeneracy, it is the initial basic feasible solutions allocations. Here we will make into the 1 second. Hello, madam. Okay, madam. లేదు వచ్చేస్తాను 7:30. ఎన్ని గంటలకు ఉంది? ఓకే, మీరు వెళ్ళి వస్తారు కదా ఈవినింగ్ ఎన్నింటికి వస్తుంది? ఒకసారి మాట్లాడి వచ్చిన తర్వాత నాకు ఫోన్ చేయండి. మోస్ట్ ప్రాబ్లీ ఈ రోజు కలిస్తే బెటర్ అని, ఎందుకంటే రేపు మళ్ళీ ఆయనకు టైం దొరకదు. క్లాసులే టైం మండే నుండి ఆయనకు ఫ్రైడే వరకు ఆయన టైమే దొరకదు. మళ్ళీ సాటర్డేస్ అంటారు కదా, అట్లా ఉంటుంది. సండేనే కాస్త కూర్చోవచ్చు. అదే వచ్చి కలిసేసి అంటే ఏం లేదు, ఈయనకు మోడిఫికేషన్స్ ఇచ్చేసే, అంటే ఇప్పుడు స్టడీ మోడిఫికేషన్ చెప్పేసి వస్తే బెటర్ అని. ఫోన్ చేసి చెప్పండి, నేను ఇమీడియట్ గా 1/2 అవర్లో అక్కడ ఉంటాను. మేడం నెక్స్ట్ మంత్ చూద్దాం మేడం, ఈ మంత్ వదిలేయండి, నెక్స్ట్ మంత్ దాని నుండి తగ్గిద్దాం. ఓకేనా? ఈ మంత్ కొంచెం కష్టమేలేండి, ఎందుకంటే వర్క్ చాలా ఉంటది. ఈ మంత్ కు చూద్దాం, నెక్స్ట్ మంత్ నుండి తగ్గిద్దాం మేడం. ఈ మంత్ అయిపోతుంది. ఓకేనా? ఓకే మేడం. Now here, solve the traveling salesman problem. Like this, he will ask in that. Here, degeneracy conditions. Degeneracy conditions means it is a here also. Here, basic solution. Originally, it is m plus n minus 1 allocations. If we get, it is gives that is the occupied cells. How many we require? That is the assignment is will be the optimal transportation problem. We can be obtained. Sometimes it is not happen. That is a m plus n minus 1 allocations. Here, generally I'm talking that is a total what we are discussing. That everyone should be remember that. While I will enter into the concept one by one, same all the serially I will discuss. Here, what is a degeneration means? It is a required m plus n minus 1 allocations in the transportation problem that is called as the optimal solution. In that, if it is not that is not there, it is a m plus n minus 1 allocations. Such cases, m plus n minus 1 allocations, it is a not having at the time, and m plus n minus 1 allocations are not there. At the time, we will go for that conversion to the m plus n minus 1 allocations. That is the concept is comes the minus 1, it comes to the degeneracy. That is we can be modified by using that is a optimal solution techniques that is called as a covering of the lines, then it is automatically we can be changed into the m plus n minus 1 allocation, so that we can obtain the optimal solution. These are the concepts we have to study in this unit. This unit is the most important and easy unit, and one long question we can get from here, and two short questions and one long question we will expect in this problem. Particularly, the initial feasible solutions body method is everybody be ready for that, because of in the end examination in the question paper we can see direct questions. It is a on a transfer problem mean it is a Modi method, either Modi method or then second is comes to the initial basic feasible solutions. On the initial basic feasible solutions, use that we can go for that is a Modi method. This is a we are going for obtain that is a optimal solution. This is a overall idea what we are going to learn. Okay, this is a total concept. Now coming to the one by one. First of all, what is the definition of the transportation problem? That is I am coming to starting. Now, first, you can easily understand this table here. Inside, what are the warehouse? Here, this problem is called as the warehouse problems. Transportation problems all will be coming to the warehouse problems only. In that warehouse problems, first it is a young warehouses we have that is called as the origins. Whereas a commodity is a stocked and this is to be the delivered and end destinations. It is called as a demand. So here origins we will be distributed to the distribution centers. Origins are allocated to the distribution centers by availability and demand. By availability and demand, that problem is called as a transportation problem. Here, X11, X12, X13, X21, X22, X2n, XM1, XM2, XMM, MN. All are the variables. That variables are clearly here. How many units of allocations we will selections we can be take. That is the idea of that solution variables that we call as the variables or solution variables that we will consider. Here, how many units of that we want to be considered. Next, it is a C11 is a shipping cost from origin to destination. C11, C12, so on, C1n. C21, C22, C2n, and CM1, CM2, so on, CMn. These all are the one is a shipping cost from the origin to destinations. Now, here origins are availabilities. Availabilities are A1, A2, so on, AM, and demands are the B1, B2, so on, BN. Best example here. I have a companies 1, 2, so on, M companies we have. M companies, that production will be the manufacturing production will be the A1 units and A2 units, so on, AN units. Here, first company will give that is A1 units of production, and A2 give that is its origin to give that is a left side origin to give that is a A2 kind of the production availability. That is my company product. It is coming to the availability in the market is that is the A1 A2. Now, company having and that is the material is available with me. That all availabilities I should send it to the market. Then I can get that is a profit. So that availability of material I should distribute to the distributor centers. So first I will identify the distribution centers. Here, where is the distribution centers means it is a location from city 1 and city 2, city 3, so on. They are city up to n destinations will be there. So destination 1, D1, and destination 2, destination 4, destination n. My availability I should be distribute to the destinations. After distribution, how much amount I am distributing, that is called as a X11, X12, X1n, like that. Already it is a shipping cost. It is a distribution point of view. I have to spend some cost. How much cost I should be spent? C11, C12, so on, C1n cost, like that. It is a CMN, means it is a each unit from the origin to destination. Directly it is a cost is different. C11, for example, it is origin 1 to destination 1. Destination means city 1. Here my company is having some the Balapur. Now I want to distribute, that is a distributor is a Kukatpalli. The cost is how much? Origin 1 to destination 1. Origin 1 is a Balapur. Destination 1 is comes to the Kukatpalli. So origin 1 to distribution destination center. If distribution center, if I want to transport, means it is a shipping cost. I have to buy traveling point of view, some truck or something else. The shipping cost from the origin 1 to destination for sending of the material goods, it is the cost is C11. From origin 1 to destination 2, some Amirpet, the cost is somewhat less because it is Kukatpalli is so far. Next, origin 1 to that is some another city n. It is a Samyapur, so it is a so far. So the cost is a C1n. Now it is a origin 2. I am taking that company is having here. It is into the Bhupalpalli. Now that is a product is some another product. That product, if I want to send it to the market, it is a destination. It is a destination 1 and destination 2, destination 3. It is a n destinations we have. The same product here, for example, here 1, 2, 3 Coca-Cola, Pepsi is in company's origins. I have, if I feel I have, it is availabilities of that production will be coming to the Coca-Colas are the A1 and Thumbs Up is the A2, Majas are the AM. That is my availability. That all are I want to distribute to the distribution centers. Some Kukatpalli area is a destination 1. and the Amirpet is a destination 2. So on like that, it is a somewhere it is a destination n. Now in that distribution, cost are the C11, C12, so on C1n, C21, C22, so on C2n. Next, see, like that is the different transportation cost we have. Here, how many units of availability? For example, it is a Kukatpalli people. I have some 300 major bottles I have. The Kukatpalli people, it is only one distribution center. They will expect that is a 1 day. 1 day here, 300 bottles is if I send it to there, here they are using only 100 bottle only they are selling. At the time, why should I send that is more than 100? It is a loss for me. So that all another 200 I will send it to the another distribution center. So Amirpet I will send to some more 80, and another is I will send that to some more city. So that is a amount of the bottles. So that X1, X2, so on, Xn all are the how many bottles of you are distributing to the which place. That is called as a destination. Now it is a demand is a here demand is a Kukatpalli people. How much demand here? It is a distribution center 1 Kukatpalli. They are asking the B1. B1 means just now I said it is 100 bottles only. So B1 is a bottles, number of bottles they will tell. Here my manufacturing company, our availability is it is coming for a day in the market is a A1, A2, so on AM. That all I should be distribute to the as per the demand of the destinations. So demand B1 for the destination 1, demand 2. Like that, all distributions I have to be distributed. So what is the requirement of the availability we need? Before that, I have to be collect and I should give into the product for production. So that production will come to the market outside. That production I have to distribute to the destinations. So various places. Then automatically it will be the origin to destination distribution centers. If we distributed, then how much cost it is happening. That cost is I want to minimize the transportation cost. That is my ambition to reduce the total transportation cost for distributing the origins to destinations, various commodities from based on the availability and the demand. This problem is called as the transportation problem. This problem is called as a destination transportation problem. It means that here in your exam point of view, one table he will give. In that table, your cost he will give and corresponding availability he will give and demand he will give. For example, availability and demand both are the same. That is called as a balanced transportation problem. Because of my company is giving that productions are the A1, A2, so on AM. But it is a demand it is a summer season. It is a product is more sellable. It is a winter season. If I want to sell, is it correct? Here I have taken that is a 3,000 bottles. I am preparing for that is from the origins of the production. That all bottles can I send it to the destinations without a demand? No, your demand is not there. Why should they purchase that is a distribution places people? If the distribution people is they will ask, then I have to give that is a production. So here, such cases, it is a demand and a supply availabilities are the exactly equal. At the time, I will not get that is any loss. Here, availability are more, but the demand is less. At the time, who are the company owners are there, they will be lost. Then destination is a demand is more, but availability is a less. Availability less, but demand is more. At the time here, the distribution center people, they will be lost. So it is a loss with both should not be in the loss means it is a demand and supply must be the equal. That problem is called as a balanced transportation problem. So origin various here, simply we can say that is a definition. Definition is a here various commodities from origin to destination. From origin to destinations, the availability of origin, availability from the origin to sending to the demand to the destinations. According that, we want to minimize the total transportation cost is called as a transportation problem. This transportation problem table is we will show like this. In this mathematical formulation means I can write minimization z equal to summation I equal to 1 to m. And how many rows we have? M rows. So I equal to 1 to m. And the summation j equal to 1 to n. How many columns we have? N columns. Then Cij is the cost, and Xij is the how much requirement we have from the origin to the destination. So that is a Xij is called as our required solutions we want to be identified. So here Z equal to minimization, Z equal to summation Cij Xij we want to be identified by using the constraints are the total demand must be the satisfied and the total availability also satisfied. From that it is how many xi is x1 x11 x12 total. If I do, the total is equal to the a11. For example, here first row I am taking x11 x12 x1n total. If I added, that is equal to the a1. At the time I will not get any loss because of it is a demand is there and availability based on that I am sending to the distribution centers. And similarly x21 plus x22 plus so on x2n equal to a2. Lastly, xm1 plus xm2 plus 1 xmn equal to an. So these are the called as a here clearly subject to the constraint 1. Next is coming to the subject to the constraint. Second constraint means it is a x11 columns also. Demand must be satisfied. So x11 plus x21 plus 1 xm1 equal to b1, and x12 plus x22 plus 1 xm2 equal to b2. So on x1n plus x2n plus 1 xmn is the total is equal to bn. So these two conditions, it means that each row availability must be the equal and each column demands must be the equal. That is allocations x11 xij we want to be identified. That is called as the solutions of the transportation problem. All solutions always must be the greater than or equal to 0. Greater than or equal to 0. So how many requirements? It is not required means it is we can take the 0. It is required means how much count it is 210 bottles and 100 bottles like that. So this is a overall idea about that. These are the three conditions. One is a minimization, z equal to summation Cij Xij, and subject to the constraints summation Xij equal to Aj Ai, and summation Xij equal to Bj. For j above is I equal to 1 to m and j equal to 1 to n, and Xij is greater than or equal to 0. These three equations are called as a transportation problem. These three are called as a transportation problem. Minimization subject to the constraints and restrictions all must be greater than or equal to 0. These three conditions are satisfied. That is called as a mathematical formulation of the transportation problem. Now, here generally, if we will discuss that is a total, it is a formulation of the transportation problem means here you should be explained that is the total up to starting to here up to here ending all the equations. Now here demand and supply must be the equal. Then it is called as a balanced transportation problem. Here demand is greater than or equal to supply, or supply is greater than or equal to demand. Then it is called as unbalanced transportation problem. So this is a overall idea about that is a balanced and unbalanced transportation problems. Now coming to that, mathematical formulation of your transportation problems. Here, simply here, once you all of you read here, suppose M warehouses we have, that is called as origins, where the commodity is stocked and with this is delivered to the end destinations, where it is a demand. Cij terminologies first I am giving origins and destination. M warehouses, M origins and end destinations. Let Cij denote that is a unit cost of the transportation from warehouse I to destination J. So origin to destination transportation cost and the transportation cost is a Cij. Each C11, C12 like that. Its corresponding origin to corresponding destination. Next here, all AI means availability for the commodity, and Bj is a demand for the various destinations. Then the table we should be draw it. Then after that is a minimization z equal to summation I equal to 1 to m summation j equal to 1 to m Cij Xij, and Constraints are summation xij equal to ai, summation xij equal to bj, I equal to 1 to m and j equal to 1 to n, and xij greater than or equal to 0. This problem is called as a transportation problem. This problem is called as a transportation problem. Otherwise, define that is a transportation problem is you should write these all. Otherwise, you explain that is a mathematical formulation of transportation problem is you should be write these all up to here. The special cases are the balanced and unbalanced. That's all. This problem can we solve by the using that is any other methods? Yes, this problem we can solve by the simplex method. Simplex method also we can write expansion is a mathematical formation is we can write like this. Minimization z equal to c11 x1 1 plus c12 x12 plus so on c something mn into xmn. So that like that all the rows will be added xi x11 x1 to so on, then a1. Similarly, second row a21 x21 x22 x23 so on. If you added x25, that is a xa2, x31 so x32 so on xa3 and so on, that is a a3. And columns also if you add it, that is a b1 b2 b so on bn, and all the variables are greater than or equal to 0. This problem is a minimization set so that z equal to c11 x1 plus c12 x2 plus so on c1n xn, and it is a balanced, so summation ai equal to summation bj. So this problem is called as a transportation problem. Transportation problem we want to be converted into the linear programming problem. That linear programming problem is a here bottom it is explained. Now exam point of view, here one theorem it will be there. What is the necessary and sufficient condition for the existence of the feasible solution to the transportation problem when it is balanced? At the time here the condition is a summation ai equal to summation bj. Here total rows if I added, what is the summation I equal to 1 to m summation j equal to 1 to n xij. Row it is a total, it is a summation ai, and column also it is a summation j equal to 1 to m n and summation I equal to 1 to m xij equal to summation of j equal to 1 to n bj. And this means that is a summation I equal to 1 to m ai equal to summation j equal to 1 to n bj, which implies that is a necessity. So converse point of view, it is a summation of ai equal to summation of bj if I take, then above conditions is a summation of xi, it must be satisfied, it is equal to the summation of bj, so that it is a lambda I into bj I will take lambda I into k, so that is lambda 1 equal to, then like it is a, if we arrange that is a feasibility we can get. Therefore it is a necessary and sufficient condition must be satisfied that summation ai equal to summation bj. That's all. Up to here it's enough. Next it is coming to the problem solving point of view. Finding the initial basic feasible solutions, you will ask the question. So finding the initial basic feasible solution, we have that is a total number northwest corner rule and matrix minimum method and Vogel approximation method. By using three we can identify that is the solution of this problem. Here whenever that is a transportation problem, generally we get that is m plus n minus 1 allocations, all are the independent. Then these allocations it is happened that it is called as a required optimal solution for the initial basic feasible solution. So it may be that is a optimal solution. If it is not optimal, we will apply that is a UB method, Modi method. From that we can get that is a optimal solution. This is a degenerate conditions living of that it is m plus n minus 1 occupied cells it is needed. Now I will explain that is a northwest corner rule. Northwest corner rule means it is this is a problem. Now this same problem I will take on the board and I will explain that. Okay. Once again, I will solve on the board. Okay. Now I'm taking board. Okay. Okay, ma. Northwest corner rule. Method. Northwest corner method. What is the meaning of the northwest corner method? It means the first I will explain one problem. Then easily you can understand. Here origin 1, destination 1, destination 2, destination 3, destination 4 he gave in your textbook. Origin 2, origin 3. My availability and demand I am giving here. Here availability here, it is a 7 for that origin 1, 19 and 30, 50 and here 10. Then here origin 2, 70, 30, 40 and 60. And then 40, then 8, then 70 and 20. Then it is a requirement. Availability is we can take 7, 9 and 18. Requirement is goes to the 5, 8 and 7 and 14. So this is a he will give the transportation problem. He will ask that is obtain the initial basic feasible solution. So obtain the initial basic feasible solution. What shall we do here? First we will take that problem here. 19, 30, 50 and 10. I will take the boxes. This is a D1, D2, D3, D4. This is a step 1 number. Step 1 is the given. Step 2. Here, origin 1, 2 and origin 3. All boxes you put. This is origin 1. Origin 2, origin 3. This is a requirement. Here, 70, 40. Here I will write that is a small. Okay. Here it is a 30, 40 and 60. Then 8, 70 and 20. Next requirement is a 5, 8, 7, 14. Now, what is a north? First of all, I will take the north. North means it is a starting element is called as a north. Starting element, what we have that is called as a north. This is north. I will start from the north. This is north. From north, I will take that as a, this is a requirement and availability. This is availability 7, 9, 18. Here demand is how much? 5. Which is a minimum? Minimum of the demand and supply. Minimum of availability and demand. Here minimum of availability. Availability is how much? 7. Demand equal to how much? 5. So demand ఎంత ఉంటే అంత ఇవ్వాలి. Demand తక్కువ ఉంది. So the demand I will allot here. 5. Then it's a demand is completely allotted for that. Some destination means that is a total I will remove. It is a 7 minus 5. How much it is? 2. Next, I will go to the moving to the north. North I am moving. Here, demand and supply. This is the shipping cost 30. It is 19, 30, 50. These are the shipping cost. Now, how many bottles are, how many demand is asking? Availability already, origin 1, already we have only 7 products. Out of 7 products, already 5 products are the allotted for the destination 1. How many we have? Only 2 availability will be there. First origin 1 I will distribute. Here origin 1, here pending are the 2. Next demand is a 8. So here immediately that availability I will distribute to the demand 2. So here I will allot. 2 is the requirement, is the 2 allotted. If we allotted 2, what are the balance are 6. Balance are 6. So here total availability I am cutting here. Then coming to the next, what is the demand and supply minimum? Here 6 and 9. Out of a minimum of the 6 and 9, it is a minimum is a 6 only. Now I will come to the west, northwest. West is asking that it is a 6th demand will be there, but availability is the that is the center origin is 9. So 9 availabilities, it is a 6 demand. Demand is a less, so the demand I will allot. So total allotment of the demand will be over, and it from the destination 2. Remaining is how much will be there? 3 only. Next I will go for that is a north. West over, then I'm going for the north. North also here availability is the only 3 in the origin 2, destination is a 7. So here I will allot that is the only 3. I will allot the 3. If you allotted 3, remaining is how much? 4 only. Next I will go for that is a down, west only. In that west it is a availability is a 4, but demand is how much? Sorry, availability is 18. Demand is 4. So that I will allot the demand. Minimum is the demand only. So here availability is a 14. Next it is a destination 4 required. It is a only 14. Demand and 14 availability. So balanced. So that it is a clearly problem is solved. Therefore, optimal solution is therefore initial basic feasible solution. Feasible solution. What are that? It is a origin 1 to destination 1. Origin 1 to destination 1. How much you are Xij you are allocating? 5. 5 quantities you are giving. Cost is how much? Unit cost. Cij. Unit cost is how much? 19. So total will be the cost is the total cost is the we can get here. Yeah, Cij into Xij. So 95. Next, coming to the second, what is allocation we have? Origin 1 to destination 2. Here, how much you amount you allotted to? Your destination unit cost is a 30 rupees. So that 60 is the cost. Next, origin 1 is over. Now I am going for the origin 2. Origin 2 to the destination 2, it is a unit 6 units allotted with the cost of 30 unit cost. So that it is clearly we can take that 6 into 30. 6 3 is a 80. 180. Next, it is coming to the down, not down, it is a side. Again, quantity origin 2 to destination 3, it is moving. At the time here, there it is allotted for that 3 units and 40. So 120 itself. Next, origin 3 to destination 3. Origin 3 to destination 3 is the 4. It's the cost is a 70. So 7 4 is a 28. Therefore, total cost is minimum. Our optimal cost is clearly here. We can take the 8 plus 8. Yeah, 10 and 18 means it's a 24. 24 plus 9. 33. Yeah, 3, 6, 7. So 735 is the optimal cost. Optimal cost. This is a, we want to spend this amount, then only it is a profitable. This is the overall idea. Okay. Once I will go to the problem, I will show you. Five into 19, 2 into 30, 180. Means here it is how much it is? 9 here, 90 here, 10, 18, 18, 19, 20, 24, 24, 31, 31, it is 12, 25, 6, 7. ఎందుకండి ఇక్కడ తక్కువ పడింది? Here, sorry, it is a 14, 14 into 70. Last is a 14 allotted. 14 into 70. So 980. The cost of 980. So 1015. This is the overall cost. Okay. This is the overall idea how we can do the problem. Once I will share this screen, once you can check it here. What are the steps I did? The same thing here, you will reflect into the step 1, step 2, step 3 like that. Now, obtain the initial basic feasible solution in the transportation problem. My screen is visible.
Yes,
Hello?
sir.
Okay. Here, obtain an initial basic feasible solution to the following transportation problem to the northwest corner method, and also compute the cost of the transportation. Here, origin 1 to destination 1, it is a supply. It is a 19 is a unit cost, shipping cost. Availability and demand requirement. Availability is a 7, requirement is a 5. So which is a list? Your demand is a 5 only. That 5 is a 5, so that the corresponding row in the column I will allot. What is that? It is a 19 is a unit cost. C1 origin 1 to destination 1 I allotted. So O1 bracket of O1 to D1 is highlighted, that is Xij equal to 5 units. That cost is 19. So 19 into 5. That will come into the last. See here, 5 into 19. Total cost of the transportation. Next, it is coming to the second step. Already it is a demand is over. So the demand cut it. Next demand we have only D2, D3, D4 only demand only. We will availabilities we should be allocated. Here already demand 1, origin 1 already allocated, so that what is the pending balance will be there? Pending balance is clearly 2 availability are available. 2 units of availability. So if I allot that is a 2 units of the availability, 2 units of the availability. Next, it is a demand 2 from the origin 1 I allotted for this availability 2. So at the time balance of the demand is a 6 only. It is coming to the step. So 9,6 it is minimum is a 6. So that I allotted, but the 2,8 is a 2. So here there I allotted that is a origin 1 to destination 2 is a 2 units of the availability. That unit cost is a 2 into 30. So that amount is a 2 into 30. You can see in the last. Next, I'm going for there is a third step. In the second step itself, then immediately it is a availability and demand. Demand is a 6 and the availability is a 9. So how much it is balance? It is a 6 is a balance. Already are 2 allotted. No? 2 allotted means it is a 2 means 6 available. 6 allotted. 6 available means 3 is a pending. 3 is a pending means it is then again we move into the step 3. Origin 2 to destination 3 allocated to the 3 units of the left onto the origin 2. So that 3,7 minimum equal to 3. The remaining demand of 4 units at D3 is now met into the Q3. So that it is ignored to the D3 column. Then like here, all the allocations are allotted. I can get that is this is the problem. So here north to west, sorry, first is north, then west, then north, then west, then north. This problem is moving to the 5 to 2, 2 to 3, 6, 6 to 3, 3 to 4, 4 to 14. And unit cost, we will multiply it to the corresponding elements. Then we can get that is the optimal cost of the transportation. This problem is called as the initial basic visible solution of the transportation problem by northwest corner method. By northwest corner method. It's our required answer. Next, matrix minimum method. Matrix minimum method or lowest cost method. In that matrix minimum, entire cost. What are the costs we have? 1930. Hello? My voice in a
Yes, sir.
Yes, sir.
Now, here, matrix minimum. Minimum means it is the lowest cost. Origin 1 and destination 1. Which is the minimum? 19, 30, 50, 10, 70, 30, 40, 60, 40, 8, 70, 20. In that, which is the minimum cost? Shipping cost, transportation shipping cost is minimum.
5.
Respond.
5.
5
Five.
8 only. Cost, not the availability and requirement. Not availability and requirement.
8, sir.
Only 8. So for that 8 is available origin 3 to destination 2. In that availability and demand, which is available here? Availability demand is 8 only required for the destination 2. Requirement is how much? 18. Sorry, availability is 18. Demand is 8. So I can allot that is a total 8 of the demand to the corresponding origin 3 to destination 2. That's all. And it is we can allot that is a 8 to the 8 only. So one column is over. Okay, this I will explain on the board. 1 second. First one, northwest is over. Now I am going for that is a low cost minimum method. Now here, so here destination 1, destination 2, destination 3, destination 4, origin 1 and origin 2 and origin 3. Now here it is 19, 30, 50 and 10, 70, 30, 40, 60, here 48, then 70 and 20 he gave. In that availability and requirement, availability or he mentioned that 7, 9, 18. Requirement is clearly we have 5, 8, 7, 14. Now your total balanced or not? This total, if we left side, if we do the total is a 34, right side also total is a 34. So it is clearly balanced. If it is not balanced, we will go for the not balanced method. That will come to the last. Now anyway, it is a balanced problem. Now I'm going for that, which is a lowest cost method. Lowest cost or least cost method. I'm using the least cost method. Least cost means here, what is the least amount? What is the least amount? This is the least amount.
8.
8 is the least amount. For that 8, I will allot that its corresponding availability and requirement. Availability are 18 and requirement is the 8. So this 8 is I will allot to that demand 2, and it is a 8 allocated. 8 allocated. So its corresponding demand, its demand is the destination center over. Then the remaining is out of 18, 8 will be over. So that balance is a 10 will be there. Balance is a 10 will be there. Next, I am going to the second. Already this column left. And none other than that column under that line. What are the minimum elements? 19, 50, 10, 70, 40, 60, 40, 70, 20. Which is the minimum element? 10. 10. Here,
10.
if I want to allot it to the 10, here availability is how much? 7. Demand is how much? 14. So minimum of 7 and 14, I can allot the 7 only. 7 I allotted. So availability will be over. What is the pending is a demand is a pending. It is a 7 will be the pending will be there. Next, already this row also left because of that availability already allotted. Next, what is the next element? Non-touching, that is the elements, lines. 70, 40, 60 and 40 and 70 and 20, which is minimum?
20.
20.
20.
20 will take, that is a next least element is how much? Demand and available supply. Demand is a 7 and requirement is availability is a 10 and demand is a 7. So I can do that in 7 itself. So 7 I am allotting for this problem, this cost. If I allotted the 7, the balance is a 3 will be there. So it's a column will be left. Column will be left. Next, what is the minimum element? Non-touching of the lines. 70, 40, 40 and 70. In between, which is the minimum?
40.
40.
40.
In between, your 40s are the 2 are there. From that, you can use the anyone. So I am taking, that is the first one I am taking here. If I take here, what is availability? 7. Sorry, 9. Demand is how much? 7. 7 and 9, which is the minimum? 7. So the total demand I will allot to this and I will remove. The balance is the 2 will be there. Next, already lines after non-touching the lines, we have only 2 elements. One is a 70 and 40. In that 70 and 40, first element is a 70 if I take. What is the least? 40 first. First 40 is the least element. In that 40, availability only 3 will be there. Requirement is how much? 5 will be there. So availability first allotted. Availability 3. 3 allotted means its corresponding row will be over. Next, pending is a 2 only the demand. So here, cost is allocated to the 3. Remaining balance is how much? Next list means only one element, it will be the same, 70. In that 70, availability of the 2 will be the balance and requirement also 2. So that 2 I will allot. So that totally amount will be the distributed. So optimal cost is how much? It is first one is 19 into 2 plus 10 into 7 plus 40 into 7 plus 40 into 3 plus total. If I do that I can get that is a total optimal cost like this. That we can be seeing this problem. All of you, once you check this problem, what are the steps we did? Same procedure in the lowest cost entry method. Minimal matrix minimum method. See, here matrix minimum method, we mentioned that clearly. This is the problem. Now I identify that the least element is the 8. That 8 is the availability and requirement allotted. Next, availability and demand. Same procedure. If we apply it, then I can get that it's a total transportation cost 814. But here observation, if he compares to the northwest, it is taking that how much cost it is 1015 cost is appearing. Now if I go through the least cost method, it comes to the 814 rupees. So which is method is best? This method only the best. Lowest cost method is best. Now I will compare to the next. I will go for that is the Vogel approximation method. Okay. Once all of you check that for problem, once read, I give the 3 minutes time. Once you read and whether you understood or not, once again you ask me. Wherever you have a doubt, I will clarify. Both the method, northwest and least cost. Do it fast. All the textbooks are available with you, know. Step by step procedures once all of you read it, then easily you can understand. Next, we will go to the vowel approximation. Once you read it, you have any doubt, please call me that. I will explain in this place. Okay, now I will go for the vowel approximation. Anyone have any doubt in the northwest and lowest caste? Anyone have a doubt? Please ask me.
No, sir.
No. Okay, fine. In this vowel approximation method, here vowel approximation method, find the cost of the transportation, he will ask. In that vowel approximation, here penalties we should be identified. Penalties we should identify. After the penalty is the maximum, which is a maximum penalty will be there. That corresponding row or column we should allocate to the based on the supply and demand. That is a special condition is called as a penalties. Penalties I should be identified. Each row and column. From the penalties, which is the highest will be there. In that row or column, we will allocate that corresponding based on the supply and demand, that respective cost will be the allocated. This is the overall idea we will be apply for this vowel approximation method. Now, I will explain this problem on the board. Vowel approximation method. Next method is a Vogel approximation method. In this Vogel approximation method, he will give that is a D1, destination 1, destination 2, destination 3, destination 4, and destination 5, and availability. AV means availability. Origin 1, origin 2, origin 3. Three origins here. And a demand will be there. That is called as a requirement. Now cost. Now at last is the penalty. Here also penalty. Now here cost he gave that CIJs 1, 9, then 13, 26, then 51. Availability is a 50.
36, sir.
36. Okay, ma. 36. Availability 51. Availability is a 50. Next, origin 2, 24. Demand is at 12, then 16, then 20, then 1. It's a 100 hour availability. Here 14, then 33, and 1, then 23, and 26. Here 150. Total availability and his demand both must be the same. 300, 70, 50, 40, and 40. Its corresponding availability 50, 100, and 150. So the total is how much? Total availability already given. No? Penalties I want to identify. Penalties I want to be identified. Now here penalty means it is a least element and next least element. I want to identify least element in the row, entire row. Least element is how much? First row,
One.
least element.
1.
1. Next least.
9.
9.
Difference between these two.
1.
Least is the 9. 1. Next least is the 9. Difference is how much?
8.
8.
That is called as a penalty. That corresponding row. In that next row also least is 1. Next least is almost 12. So penalty is 11. Next is a origin 3. Least is 1. Next least is how much? 14. So penalty is 13. Column wise also. Column least is 1. D1. Destination 1 is a penalty. So here 1 is the cost. Next to 14. So demand is the penalty is the destination 1 is 13. Next is a 9. 9 and 12. How much? 3.
3.
Next is a 1 and 13 is a 12. Next is a 20 and 23 is a 3. Then next is a 1 and 26, 25. Now, in that, which is the maximum penalty?
25.
25. Where is the 25? It comes to the D5. So in that D5 you select. In that least cost, lowest cost is how much?
12.
3.
Only D5. The 25 will come to the D5 only, no? The D5 column only you should check.
1.
So this 1 is I allotted for that is the corresponding, which is the availability and requirement is the minimum. Here availability is 100 and requirement is 40. Demand is 40. Which is the least? Demand is 40. So I will allot that is 40. 40 allotted means it is a corresponding D5 is over. Then pending is how much will be there? Only the 60 will be there. Am I clear?
Once
All
again
understood?
explain, sir.
Sir, ఒకసారి explain చేయండి.
Okay. Again, I will write this. He gave that 1, 9, 13, 26, sorry, 36, 51. Availability is how much? 50. Here, 24, 12, 16, 20, and 1, 14, then 33, 1, and 23, and 26. It's corresponding 100. This is the 150. Here it comes to the 100. Here it comes to the 70, 50, then 40, then it is 40. Now here, first row or first origin I am taking. Least element and corresponding least element I am finding. Least element is how much? Least element is 1.
1.
Next least element is 9. The difference is how much?
8.
8. That is called as a penalty. Next one, least is a 1 and the next least is 12. So penalty is a 11.
11.
Least is 1 and next least is a 20, 14. So penalty is a 13. Third row. Origin 3 over. Next destination 1 penalty. Least and the next least. Least is a 1 and next least is a 14. So difference is a 13. That is called as a penalty. Next list 9 and 12. Difference is how much? 3. That is a penalty. Least is 1. Next list is a 13. Penalty is how much? 12. Least is a 20 and next list is a 23. Penalty is a 3.
3,
Least is a 1 and next list is a 26. So penalty is a 25.
25.
Highest penalty first you select. Highest penalty goes to the last column. That is a D2, D3,
24.
D4, D5. In that least element, least cost is 1. In that least cost, supply and demand, which is the minimum? 40. So that 40 is allotted. 40 allotted column. So that another all total amount be allotted to in that particular cell. So the column totally removed. Then how much it is the balance? Balance is the 60. That 60 point of I have to do, that is the next aspect. Next procedure same. Now already last column over. Penalties I will identify. First list is a 1 and next list is a 9. Well, again we continue the procedure. Next penalty is a 8. First row, first origin 1. Origin 2, least element is 12, next list is a 16. Penalty is how much? 4.
4.
Least is 1 and the next list is 14. So demand until it is a 13 only.
13.
Least is 1 and the next list is a demand point of view 13. Least, that is a 3 only. Here least 12 only. Here least 3 only. Already it will be there. What is the highest penalty?
13.
13. Either you can go by the row or column. So first I am going for the column. Your choice. If you go for the column, what is the lowest element? Lowest cost.
40.
In that row, in that column. Lowest cost enter.
1.
D1 select 1. 1 low supply is how much? Supply and requirement is how much? 100.
100.
Availability is a 50.
50.
So availability only I can allot. 50 over. Pending is how much? Another 50 will be there. So it's entire row over. Row cancelled. First row is cancelled. Next row. What is the origin to? Least element is 12. Next list is a 16. So that penalty is a 4. Continue the procedure. Least is a 14. 1. Next list is a 14. So penalty is a 13. Here already 9 is over. No, 9 already line is cutted means we should not take. So origin is 2 is a 12 and origin 3 is a 33. What is the difference? 21. 11 or 21?
21.
21. Next is a least is a 1 and next list is a 16. Difference is how much? 15. Least is a 23. 20 and next list is 23. So difference is a 3.
3.
What is the highest penalty?
D2. 21.
21. It is a D2. So I will select this D2. In that least cost, already 9 is over. Already first is cut.
12.
12.
12. In that 12, I will allot that is the least availability and requirement. Available is a 60 will be there. Already 40 allotted, no, only 60 will be there.
Yes.
Demand is a 70. Minimum is how much? 60 and 70.
60.
60. So I 60 I allotted. 60 allotted means it's a balance is a 10.
10.
10. So it's 10 entire row will be the cancel. Because of 60 already 60 over now.
Hmm.
Next, what is the penalty? Least penalty is 1. Next is the list is 1. Next list is a 14. What is the penalty? 13. First row origin and second row origin 1, origin 2 over. First row 2 rows
13.
over. Next origin 3 I'm checking. Next origin 3 already first only 14 33 will be there. 14 I will take that is a 14 itself. Only one element, no, others already origin 1 R2 over. So next is a 33. Next is how much? Difference 1,
1.
3. Already last is already cutted. Here, which is in between that, which is the highest?
33.
33. It's corresponding to the D2. So here, penalty and demand. What is that penalty and availability and requirement? Here availability is 150. Requirement is 10. So after smallest is a 10. 10 I will allot. So it's D2 will be cutted. Same continue the next to continuation. Least and next list. 13 is a penalty. And here 14. Already second D2 is over. Next is 1 and 23. What is highest penalty? 23. So 23 is it comes to the D4. D4 availability and demand, availability and requirement. Already 10 is cut in, 140 will be there. Out of 140, again I am going to allot that is a 40 itself. 40. So 40, if I give that is here 40, its corresponding column will be over. So it is a pending is how much? 100. Hello, ma'am.
Yes. Okay.
Next we will go for that is the next availability. Next penalty. 14 and what is not touched lines. That will be the only D1 and D3. Difference is how much? 14
13.
and 3, 13. Next here, 14 will be the as it is, and 1 is also as it is. Only one element will be there. Highest penalty is the 14.
14.
First the D1. In that D1, here availability 100 will be there. Requirement is the only 50 at the balance. So 50 I will allot. So 100 minus 50, only 50 are we can allot. Next here 50. Next penalty is comes to the only 1 will be there. So 1 because of here already this column D1 column is completed. Next here also 1. Only 1 is the 1 is there. How much it will be the pending 50? Availability 50 and the requirement also 50. So I will allot that is a 50. So optimal cost will come to the first one 50 into 1 plus first row is over. Second row 60 into 12 plus 1 into 40. Second row over. Third row 50 into 14.
14.
Next is 10 into 13. The 10 into 33.
33.
50 to 50 into 1 plus 40 into 23. This is called as total transportation cost. How many allocations we have? Once you check m plus n minus 1. How many rows? 3 rows. How many columns? Columns are 5 columns. Minus 1. Total is 8. 8 minus 1. 7 cells are available or not? Once you check. Here 1, 2, 3, 4, 5, 6, 7. So availabilities. Any it is a less will be there. It comes to the degeneracy. That comes to the that will be we can check into the UV mode method. Okay. This is the overall idea about it. How we can solve the problem. Now already solved this problem. Once you can check it here. Step by step procedure. This is a given problem. First, he identified the penalties. First penalties here, which is the highest means here 13. The 13 is the least element is 1. So there it is availability and requirement is allotted. Then second step, it goes to the, again, he identified the penalties. In that, highest penalty is a 25. Least element is selected and he allotted that is a availability and requirement. Like here, we will go for that is a total simplification procedure. We can get that is optimal sort, optimal cost. Okay. This is called as a 3 models for finding the initial basic feasible solution for the transportation problem. Okay, ma?
Okay, sir.
Thank you.
Anyway, you refer that and carefully you check it. You can understand easily. Once you read that total one, based on this is a initial basic feasible solution, I will discuss in the next class that is a modified distribution method. Modified distribution method. Modified distribution method gives that is the optimal solution. Above initial feasible solution, this initial solutions to be identified. The modified distribution method gives that is the initial basic feasible solutions. Accuracy value, optimal accuracy value we can get by using this method. Either stepping stone or modified distribution method. These 2 methods we can be discussed in the next class. Okay, ma? Okay. Anyway, my time
Thank you, sir.
is over.